Hi, welcome to this video in which we are going to be presenting the state-of-the-art research that could have a transformative effect on the energy landscape. It's the idea of a solid-state wind turbine. Yes, a wind energy generator with no moving parts at all. Why is this significant? It is because the largest portion of maintenance cost in wind turbines is associated with moving parts, mainly the gearbox. So make sure to watch this video till the end to learn what research is being carried out to further wind energy. On this channel, Synergy Files, we aim to inspire engineers and technicians for a better, more sustainable world. Subscribe today to get the updates of all the latest developments in the field of renewable energy. Wind energy has grown exponentially in the last 2 decades, so much so that even solar energy that is present almost everywhere is still playing catch up. Although one distinct advantage solar has over wind is the minimal maintenance requirement. This is because solar PV is entirely solid state, meaning there are no moving parts. It's a well understood engineering principle that the lesser the number of moving parts, the higher the reliability of a system and the lower the maintenance costs. If on the other hand we look at wind turbines, we notice that there are several moving parts such as the blades, the generator, the gearbox, the high and low speed shafts. Furthermore, there are motors for yaw and pitch mechanisms. Therefore, the number of things that can go wrong with a wind turbine are much higher compared to a solid state solar PV system. There is fatigue, wind shear, creep, and vibration. All of these factors impact on the structural integrity. The resulting maintenance costs of the wind turbine are offset through economy of scales. That is, by making the wind turbines larger, the maintenance costs are made relatively lower. The rotating blades of the wind turbine experience high amount of shear because of very high tip speed. The rotation also causes bird strikes and produces shadow flicker, which is a phenomena that does not register well with the communities residing close to the wind turbine. Keeping these problems in mind, there have been multiple attempts to create bladeless wind turbines. Some of them use vibration caused by wind in a pillar-like structure to generate electricity. These designs have low yield and are still prone to failure. Having mentioned all that, the great news is that a technology which can sweep all these problems away is on the horizon. That is, solid-state wind transformers are arriving on the scene. The concept is fairly simple. A high voltage current is passed through a thin wire to ionize the air. Once the air is ionized, these ionized molecules are dispersed by the wind. This leaves a net positive charge in the ionizing apparatus. A potential difference builds up between the earth and now the positively charged ionizer. This leads to a current flow. As you may notice, it is a very simple concept but requires some electrical energy initially to act as a seed to ionize the air. Once the charge starts to disperse through wind, there is a net positive energy gain. The higher the wind speed, the more charge dispersal and the higher the electricity generated. Note that in Netherlands, researchers from TU Delft had already created a bladeless wind turbine called Evicon as early as in 2013. Evicon is short for Electrostatic Wind Energy Converter. A working prototype of Evicon is on display at Delft University campus in Rotterdam. As the input voltage for creating ions was kept low in this old model, it used water droplets for charge dispersal rather than to ionize the air particles. Now, wastage of water, however little, is never going to be an appealing option. Moreover, it limits the utilization of such generators in, let's say, freezing conditions. And those were reasons enough for stalling this technology. But a recent development has changed all that. In the year 2018, we saw the first successful flight of a solid-state ion drive airplane. It again used a very simple principle. 2 electrodes charged with a very high voltage were used to ionize the air. Electric fields were then used to accelerate this charged air. As this charged air passed underneath the wing, lift was generated. The notable thing was the potential difference between the positive and the negative electrode, which was an extremely high value of 40,000 volts. And this high voltage is the key to ionize the air. In other words, we don't need simple electrodes for ionization, but we need coronal emitters. The high voltage was something that had been missing in the early research of solid-state wind energy transformers. So all that remains is to reverse the concept of creating ionic winds, which uses the movement of charge in an electric field to create the bulk movement of air. Instead, we use wind to move the particles against an electric field to create the current. In the latter case, we also want electric field to be relatively weaker so that wind largely controls the ion motion. There is now a rush to create these devices, and universities around the globe have now increased the research in this area. This technology has the potential to generate electricity at very low monetary and environmental cost. One thing we do notice with wind energy is that it is not as ubiquitous as solar PV when it comes to domestic scale installations. Once the solid-state technology is perfected, however, it will result in wind energy transformers almost as common as solar PV. The other advantage this technology will bring is that its use in conjunction with solar PV will result in a more reliable system that provides a stable level of base load more consistently. So when there is a system of high pressure hovering above you, more electricity through solar will be created. But when a low pressure system takes over, then the solid state wind transformer will generate more. And with this, the video is concluded. If you learned from the video, please do hit the like button. This helps the channel to grow. Thank you for your attention.